Right, coming up on 90 seconds. We've got a pretty good crowd gathering with us. Looks like we're getting a quick TVC, that wiggle check.
It's my favorite view of the rocket.
Right under the launch mount. All right, so again, our hold point comes up at T-minus 40, not tracking any reason to stop there, so we should see us go right through that. All right, we are through T-minus 40. We are counting down. We're gonna let our flight director, Maciek Batura, take us the rest of the way. 30 seconds, the 10th liftoff.
T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff.
Vehicles pitching downrange.
Booster chamber pressure nominal.
All right, we're a little over 40 seconds into flight. 33 out of
Booster
33
and ship,
Raptor
avionics,
engines.
power and telemetry nominal.
Getting good call outs, healthy systems on the booster as it starts to pitch over. All right, we're a little over 1 minute into flight, about to pass through max Q.
Max Q.
All right, so we are through the period of maximum dynamic pressure, max stress on the vehicle as it continues to fly.
Our next major event is going to be hot staging, which is happening in just over 90 seconds from now. To get ready, the booster will shut down all but 3 of its Raptor engines. The clamps holding the 2 stages together will release, and the second stage ignites its engines. The ship then separates from the Super Heavy booster and heads to space. At the same time, the 3 engines still firing on Super Heavy will flip the booster around. 10 more engines will ignite for the boost back burn, putting the first stage on the path for splashdown. As we mentioned earlier, the hot stage will be jettisoned for this flight, and that should occur just after the boost back burn. So we're about to shut down the first stage and perform hot staging. So let's just watch and listen.
All right, seeing the engine start to throttle down.
MECO. Ship ignition. Boost back burn startup.
Stage separation.
Stage separation confirmed. We've got 6 engines running on ship. Booster is doing its boost back burn, continuing now towards its splashdown site.
Ship
We are
Raptor
seeing
chamber
all 6
pressure is
Raptors
nominal.
lit up on ship. You heard them report ship chamber pressures nominal, so that chamber pressure, just that expected thrust level in those Raptor engines on the ship. 3 vacuum optimized,
Ship
3 sea
avionics,
level,
power and
all
telemetry
looking
nominal.
good. There's a view into the business end from the ship.
Boost back burn shutdown.
All right, so at this point, we finished our boost back burn, so that was shut down. So that's the first of the 2 burns after a launch that the booster is going to do today. It's not going to be quite as an aggressive of a flight down. We relaxed that angle of attack a little bit, but we are then going to be looking for it to do its engine tests for the landing burn, and those are going to be a little unique this time.
Yeah, typically we start with all 13 inner engines lit for that landing burn and bring that down to just the center 3. But one of our test objectives for today is to simulate what an engine out situation would look like. So we're going to be intentionally turning off one of those center 3 and instead lighting one of the engines from the middle 10 ring.
Yeah, we did see one of those engines in the middle ring shut down during the initial ascent. Oh, looks like we have hot stage jettison. You can see it floating away there to the left of the booster. There's still a chance that engine could be back in the mix for the very start of the landing burn, so we'll see if we light up all 13. But we've even done a landing burn at the tower with an engine out, so very resilient. We'll see how it does on its way down. All right, so we got a couple of minutes. That landing burn start should be just about 40 seconds away. That's always rad. You can see the boost plume itself in the background as it was coming in. All right, about 20 seconds to landing burn.
Ship Raptor chamber pressure is nominal.
All right, here we go.
Landing burn startup.
Looks like we got 12 of those 13.
Down to 3, including one of the middle ring. Down to 2. Nice little hover. And landing burn shutdown. And into the Gulf, here we come. And the booster has splashed down.
Incredible flight for booster today.
Meanwhile, back in space, about 7 minutes into today's flight, ship continuing its ascent burn. This goes until just about 9 minutes into our flight. That ship engine cutoff is slated for 8 minutes and 57 seconds. We are going to see those 3 RVAC, the Raptor vacuum engines. Those are the bigger circles and that little indicator on the bottom right of your screen. Those will shut down first. And we continue burning for a couple seconds longer on those inner 3 before we hit SECO, second engine cutoff.
Yeah, these views are looking great. Once again, thanks to Starlink for getting us these views. It's just incredible. And we just heard the sound from booster.
It's like we just got a late boom from the booster.
Yeah, we have ship engine cutoff coming up here just shortly.
Ship engine cutoff.
We shut down those center 3. Successful ship engine cutoff.
Seco, baby. There we go. That's what we want.
Nominal orbit insertion.
All right, we just heard the call out for nominal orbital insertion.
All right, so ship is in space. There we go. We're seeing the flaps starting to move into a stowed position. That's why it looks like your camera's moving.
Super pumped to see all the team's hard work in action here today. And of course, as guaranteed, it's been an exciting day so far. We successfully lifted off right on time at 6:30 p.m. Thankfully, our weather was looking good today. Yeah, and booster, we had our soft splashdown, so ship continues on.
Yeah, ship able to complete its ascent burn all the way in. You can see some of the shadows start to creep as it's going to be eventually flying into an orbital nighttime. So we'll see some daylight start to go away. But ship is in orbit, completed its burn. And I mean, that's just the beginning. Now we've got a whole bunch more to go. So we've got some exciting demonstrations
Ship
planned
FPS is
while
safe.
we're on orbit. That right there, we just saved the FTS, the flight termination system. That's that automatic flight safety system we have on the vehicle. So that is now turned off while ship starts its coast period. We are coming up, our next milestone is going to be the deployment of those Starlink simulators. We've got some payload inside that we're hoping to deploy into space for the very first time. That deploy is supposed to start at about 18 minutes and 27 seconds into the flight, so just about 7 minutes from now. That deploy will take place over a couple of minutes. It'll go about 1 satellite a minute, so we'll be spread out over that. It might get a little dark, but we've got a couple of views that we can show you to see that deploy in action. After that, we're also looking to do a relight of a single Raptor engine while we are in space. We've done this once before. This is not necessary to deorbit as we are in a suborbital trajectory, but this is essentially a chance to test out what we need to be able to do a deorbit burn. So we'll be doing that a little bit later in the flight, about 37 minutes or so into the flight, and then we get into reentry. We're looking to get that light show and, more importantly, get that really critical data about the ship's heat shield.
Yeah, exactly. At about T+45 minutes, we'll be heading for reentry. Again, running those experiments with the tiles. We're going to be doing missing tiles, metallic tiles, and also intentionally loading those vehicles' flaps. Hopefully, we'll also see a splashdown in the ocean today.
Yeah, we were able to get to a reentry last time, but we didn't have full attitude control, so we weren't able to go in, heat shield first the way we're designed to. So we ended up losing contact with the ship before we could make it all the way through. So you still get data, but you're not really getting the data that we want to make sure we're kind of stress testing the vehicle. As Amanda just said, we removed a bunch of tiles, and we do this in some intentionally scary places on the vehicle because we're really looking, are there spots that were vulnerable to this? Before we ever start moving towards, putting ship into a full orbital mission to then do reentries a little bit later on. So really, really critical to get that data, really looking forward to a controlled reentry.
Yeah, for sure. As we always say, our main payload is data, but today we also have some actual payload on board, and those simulators will be deploying. We'll see coming up here in just a few minutes. These are dummy satellites that are about the same size as our V3 Starlinks. We have 8 in the test dispenser and expect to deploy at a rate of about 1 per minute, as Dan mentioned earlier. Starlink is critical in all of our flights and provides real-time telemetry through every phase of flight.
Yeah, we took a peek inside of the payload bay there for a second. So there's 8 of them there. They kind of look just big steel plates, essentially. They're roughly the same size. as those V3 satellites. When we do get that view inside of the payload bay, the payload door will kind of be on your right, and we'll start to see them go out like a Pez dispenser. Yeah, here's a look inside. So those right down there in the center, they're kind of 2 stacks of 4 on either side, and then the payload door is just to their right. And so we'll look to see that open, and then those satellites start to go. We vent the nose cone, so we essentially bring it down to vacuum before we open the door. That was one of the things we ran into on the last flight, as when we had that fuel diffuser fail, the pressure in the nose cone became basically too high for the actuator of the door to open. So that's why we weren't able to get the door open that time. We have not seen anything like that on this flight. Everything's looking good with our fuel tank and our fuel press system. So we are hopefully just a couple of minutes away from seeing that payload door open and getting to our first ever payload. It's not the first payload we've ever carried, but it's the first one we're going to try and shoot off into space. All right, so I think we're supposed to open the payload door in just about a minute and change. And you're seeing a little bit of residual gas. And we opened the door once. I want to say it was back on flight 3 when we were able to make it up into space. And you'll kind of see a lot of that gas rushing out into the vacuum of space. It's the residual that's left over after we've already vented it down. So kind of a cool light show. And then we'll get ready to deploy those payloads out. And as we mentioned, so we have crossed over now at this point into an orbital nighttime. So views from the outside will get pretty dark, but we'll see what we can see. We do this by design. We've been launching these later in the day to try and get daytime views when we splash down. So it's daytime over in the ocean where we are currently headed.
Just a few seconds until we expect those payload doors to open.
All right, one more time. Open the pod bay doors, Hal. So we are currently in payload deploy prep. And the door is open. All right, so the payload door is open. We should see the first satellite start to deploy at about T plus 18 minutes and 27 seconds. So should be only about 30 seconds. So one step closer. Hal listened this time. He cooperated. He opened the payload door for us. There's a view kind of behind the Pez here looking out into the vacuum of space.
About 15 seconds until payload deploy.
Ship has transitioned to payload deploy. There we go. Pew pew. Been waiting way too long to do that. There we go.
There goes another one. Super exciting moment, as you can hear the energy. Everyone's super excited for finally getting to deploy some of those simulated satellites.
Pez system moving down. Next row. There we go. As we said, we're going to do about one every minute or so. And this is just kind of a dress rehearsal for when we're going to be deploying the V3 satellites. And these are just a massive, massive increase to Starlink's capability. Each one of them has its 60 terabits per second of capacity that's going to get added to the network per launch. That's 20 times more than what we're adding with every single Falcon 9 launch today, which, you know, step increase in capability. There goes another one. All right, so as we said, we've got 8 total that we're going to go through today. It's about a minute for each one, but looking good on payload deploy. All right, so we're about halfway through. When we actually start launching the V3 Starlinks, we're going to be flying about 60 each time. So it'll be about an hour to get through a full stack. But again, it's just going to be a massive increase in the amount of bandwidth. It's going to enable, you know, gigabit upload, download for people with Starlink, you know, anywhere on the planet. And for us, Starlink is just a tremendous part of just the flight test program.
Yeah, absolutely. Always getting us that data, and yeah, the amazing views we have on the vehicle today.
Yeah, views brought to you by Starlink of us deploying Starlink simulators before we deploy actual Starlinks. How deep does it go? All right, another one firing out. Pez looking smooth today. All right, looks like we've got one left.
Almost there.
Yeah, there you go. One remaining, so 7 of the 8 have been deployed. One more to go. And then we will have completed our first ever payload deploy operation. Just a reminder, we're on a suborbital trajectory. These satellites on that exact same suborbital trajectory, they're going to burn up entirely and are on that same trajectory towards the Indian Ocean. So the last one has been deployed. Starlink simulator payload complete. Heck yeah, everybody.
Loving the energy.
There, now it's empty. Looking a little lonely, but
Successfully deployed all the simulator satellites.
really, really cool to see them all out there. Again, people that have followed know Starlink's really critical for this program. In addition to getting all those views back from the cameras, this is an external view. As I said, it's dark outside right now. The lights are off, so it's going to be hard to make stuff out. But in a little while, the sun's going to start coming up as we get to re-entry, which is going to be really critical. We use Starlink for data. Cameras also use it on the cameras that we use to bring you views of these launches and also, hopefully, of the re-entry and splashdown. We'll see what we get today. And that's just kind of how it all comes together. Like, we're using Starlink on the planet, off the planet. With Starship, we actually get pretty insane. If you're in the space industry, bandwidth to space is usually pretty minimal. We get about 120 megabits per second. That's split between our high-definition video and real-time telemetry. We get that every phase of flight, including re-entry. So it's not just giving us views of re-entry, but we're getting all of that engineering data in real time through phases that it used to be impossible to get that in real time. So just really incredible. All right, now with payload deploy complete, Pew 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 is now going to close its payload bay door and continue to coast towards Earth, around Earth, towards the ocean. Sorry, I'm really excited today. We are in space, people. Still a lot of major events to come, though. We are looking to relight one of those Raptor engines at about 37 minutes, 33 seconds into the flight, followed by atmospheric entry, hell of a light show, and splashdown. So we're going to go on a quick break, take a quick coast, sit back, enjoy the views. A little bit dark now, but they'll get better soon. A couple of space jams. We'll be back in just a few minutes for that Raptor relight and then re-entry. See you soon. All right, welcome back, everybody. If you're just joining us, we are expecting the relight of a single Raptor engine. That should be coming up in just a little under a minute. We're going to be lighting just one of those Raptor sea levels in the middle there. This is not a deorbit burn. It's a demonstration of what we'll have to do for deorbit burns, but we've done this once before. This is something we're really going to have to do when we're doing orbital missions, so it's a pretty critical test. We are just a couple seconds away. Sorry, we're about 20 seconds away, psych. So we got a little bit more time. So we are going to see one of those Raptor engines light back up. We are through the deorbit demo gate, so we should be seeing it momentarily.
Relight demo startup. And shut down.
All right, looks like we confirmed the relight of one of those center Raptor engines. Second time we've done that. Super exciting. Huge congrats to the team on this milestone. Very exciting to see.
That was a cool light show. Yeah, I get to do a mini version here. So again, that's going to be really critical for when we're doing deorbit burns. Like as you're going through, which if you don't have one of these, my God, they're so much fun. But like you're able to actually like light. Oh, man, Dan, turn it on. Light that engine. Not set my co-host on fire. And that's what we'll eventually do to, break out of orbit, come back down to Earth. So really cool to see one of those engines light back up again in space. That was our last in-space thing.
Very exciting. We're going to be heading back for re-entry at about T plus 45 minutes. So we're going to take another quick break, and we will see you soon.
Starship is approaching entry interface.
All right, so we are back. We are about 45 minutes into the 10th flight test, and as you can see, the light show has started. Re-entry has begun. We are starting to re-enter the Earth's atmosphere. We're moving about 5 times the speed of sound, and we're about to start barreling through the Earth's atmosphere and head for a splashdown. We don't plan to recover the spacecraft today, but if we do make it all the way down to the water, who knows? But the goal of this part of the flight is to learn as much as we can about the ship's heat shield. A fully reusable, rapidly reusable heat shield for a spacecraft has never been done before. It's one of the hardest engineering challenges still out there for us. And so this is a time to really dig in and get that data. Throughout history, a lot of times this is when you go into just a complete data and insight blackout, where that plasma sheath builds up around the outside of the spacecraft that blocks all of your signals that are trying to fight through to talk to either satellites out in space or towers down on the ground. Ship's big size kind of gives us awake, but what really helps us punch through is the fact that we're using Starlink. We're operating at just a much higher frequency. That's not what we want to see. So we just saw some of the aft skirt just take a hit. So we've got some visible damage on the aft skirt. We're continue to re-enter though. And again, we are intentionally stressing the ship as we go through this. So it is not guaranteed to be a smooth ride down. We've removed a bunch of tiles in kind of critical places across the vehicle. So seeing stuff like that is still valuable to us. We are trying to kind of push this vehicle to the limits to learn what its limits are as we design our next version. So 47 minutes, 45 seconds into the flight, excitement ticking up a little bit on re-entry already, but the light show is continuing. This re-entry is going to take about 20 minutes or so until our planned splashdown. We were trying to splash down about 1 hour and 6 minutes into the flight. All right, so we're about 10 minutes until we're probably going to start hearing some of the other big milestones coming up.
Yep, in about 10 minutes, like Dan said, so will be transonic. This is going to be the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, so somewhere in the range of Mach 0.8 to 1.2. For reference, commercial jets have a range of cruising speeds, but most of them fly at speeds between Mach 0.74 and Mach 0.85, so that's 480 to 575 miles per hour or 770 to 930 kilometers per hour.
Yeah, and after transonic comes subsonic. That just means you're slower than the speed of sound. We're still well in excess of that right now. But by the time we hit subsonic, we're essentially belly flopping down. There we go. There's that sunlight. So we're seeing the Earth now come back into view. We're pushing not just how well does the heat shield hold up, but how well does the ship structure hold up. We are pushing it beyond essentially what we think we'll have to fly at to do something like a return to launch site. So again, may not be a very smooth ride downhill. But we're doing that by design. We're really trying to find what are the edges that we can operate at, build up a good data set. But sun is up, clouds and water down below us. We are just about 10 minutes away, a little less than 10 minutes now, until we start hitting transonic and then subsonic. Once we hit subsonic, we're basically just belly flopping. At this point, again, the flaps are controlling, so this movement you're seeing is that forward flap moving to try and just maintain control, maintain attitude of the vehicle as we're coming down. Checking in on one of our flaps. We got one of these cameras on all 4 of the flaps, 2 in the front, 2 in the back, giving us really good close-up views. As we obviously don't have a camera that can see the entire heat shield. These give us kind of the best that we can do. But looking at those flaps is really, those are just, super critical for controlling the ship. You have some ability to maneuver kind of cross range. So as you're coming in, you can see in that indicator at the very bottom right that we've pitched up quite a bit. So again, we are maximally stressing those aft flaps right now. It's like we're still maintaining control. All right, flaps earning their paycheck today, getting through kind of that max stressing. Here we go.
Landing burn startup.
Seeing 3 engines. There's our flip. There's a buoy.
Oh my God.
There's a splashdown.
Oh my God.
Hey. Oh man, yeah, farewell ship 37. Thank you, buoy cam. Landing flip, landing burn, splash out, there we go. All right, that was pretty awesome.
Incredible
This is
flight
cool, right?
today for both ship and booster.
Yeah, really incredible. So obviously we're excited here. It looks like everybody's excited over there. Tyler, how's it going?
We're super excited here. It was another exciting flight test in the books, and we hope you enjoyed those Starlink views. So congratulations to the team, everyone here and around the company. So many employees have contributed enormously to the program as we continue to iterate and make progress towards a multi-planetary future. So that's going to wrap it up for us here.
It's been a year. Everybody that's worked on this program, this is what we're working for. So big congrats to all of them. Thank you to all of our future customers too for your support. We just launched the world's biggest rocket. Again, dropped a couple satellites off, suborbital.
Incredible payload deploy for today.
Nailed that double header into the ocean, splashdown, time to go through the data. Really crazy cool to hit all those objectives today.
Yeah, huge shout out to all the teams who make this look easy. And thanks to all of you for tuning in, and we will see you back here for Flight 11. Good night.